students, the topic for us to understand in this video is a couple and the movement of a couple. Now first let's try to define what a couple is. A couple basically means two equal and opposite parallel forces not acting along the same line. So two equal and opposite parallel forces not acting along the same line constitute what is known as a couple. Now to understand this, supposing here is your meter rule. Say there's a meter rule here. This is your axis of rotation. So either it's kept on a knife edge or is pinned to the wall with the help of a nail. Now if supposing there are two forces acting, one this direction and one here, and both these forces are equal in magnitude, okay, meaning 10 Newton here, 10 Newton this side. Now this is what constitutes a couple. Two equal and opposite parallel forces not acting along the same line. So means not here along the same line, but separately here. There's a distance. There's a distance of separation between the two forces. It could be this way or it could be, say, this way. Now why I've made two drawings is to show you that the movements produced, the direction produced in both the cases is different. Now if you look at the first situation, because of this force, this meter rule is being pushed upwards. So this is how it moves. Here, because of this force, downward force, this meter rule is going down. So if you notice, clockwise, the lower force is also creating a clockwise movement. So the total movement in a couple adds up. Okay, like for example, if I was to just put a few values here, supposing I put some numbers, say we actually calculated and we'll be actually doing some sums based on this. Say we got a movement created by this force as say 50 Newton meter. Okay, and this is clockwise direction. So according to the sign convention, this is minus 50 Newton meter. Here also minus 50 Newton meter. So minus 50 and minus 50 is minus 100. So see, the movement created by a couple is far greater than that of a single force. It's double. Here also in this case, supposing this was 50 Newton meter, movement created by this force, and the moment created by this force was 50 Newton meter, and these are anti-clockwise. See, this force is making this rule turn anti-clockwise, and here also because of this weight, it's falling down. So this is anti-clockwise movement. It's opposite to the movement of a clock. So anti-clockwise movement is taken positive. So plus 50 and plus 50 makes it a plus 100. Okay. So we can again see that the resultant movement of a couple is twice, double that of a single force. Okay. Now where is this applied in real life situations? So opening and closing a tap. Now I'm talking about the conventional taps. Okay. Every time you open and close a tap, you are using a couple movement. Opening and closing a bottle cap, again couple. You have realized how difficult it is to try and open with one finger. Okay, but if you use both your fingers, the cap opens very easily. So opening and closing a bottle cap. Turning a key in a lock, that is also example of a couple. Okay, and steering wheels. Nowadays, of course, they're all power steering, so small ones, people drive with one hand, but the conventional ones, those big ones, if you have seen the buses and all, they used to be pretty large in size. Okay, again to this distance, to increase the distance. So steering wheels, so when you are holding it both hands and turning it, you are applying a couple there also. Now let's calculate what is the resultant movement of a couple. Resultant moment of a couple. So say we have a situation where there is a meter rule kept on a knife edge, or this is pinned. So this is the axis of rotation O. We have two equal and opposite parallel forces. So this is F2, and this side on my left hand side I kept F1. This distance from F1 to O is D1, and this distance from F2 to O is D2. Okay, and the total distance between the two forces, I'll take it as capital D. Now, let's first calculate the individual movements due to force F1 and force F2. So, movement due to F1. The formula for torque, okay, if you remember, torque is F into D. So, I'm just applying the same formula, F into D. So, movement due to F1 will be F1 D1. The distance from the axis of rotation, perpendicular distance is D1. Now, moment due to F2 will be again the force F2 multiplied by the distance D2. Now the resultant moment. Now in this case, what we say is this force is making it move anti-clockwise. Here this force is also making the rule turn anti-clockwise. So both are anti-clockwise, meaning both are positive, anti-clockwise. So the resultant moment, the total moment is F1 D1 plus F2 D2. Now, if you remember, the definition of a couple was two equal and opposite parallel forces. Now, though I have written F1 and F2, that is just to distinguish between the two forces. They are supposed to be equal. So, what I do is I can take F1 and F2 common as F. Why? Because they are equal. Okay. And then in the bracket, I have D1 plus D2. Why? Since F1 is equal to F2 is equal to F. They are equal. Okay. Now this D1 plus D2 is nothing but the entire distance between the two forces, meaning it's capital D. So the resultant moment of a couple, we get F multiplied by D. So if the definition of the resultant moment of a couple will be, it is the product of any one force. Because they are equal, you can just choose any one force and multiply it with the distance between the two forces. So this distance between the two forces, capital D. Okay. So the product of any one force and the distance between the two forces gives us the resultant moment of a couple. Right. So please keep this in mind. This will help us to solve the numericals very quickly, easily. Okay. Okay. Let's discuss this formula with the help of one example. Say we have a situation. Right. 20 Newton, 2-meter distance, and we have again a 20 Newton also at a distance of 2 meters. Now if you're asked to find the resultant moment, okay, the first thing after observing this question is that you should realize this is a couple, okay, two equal and opposite parallel forces not acting along the same line. So here resultant moment of the couple will be F multiplied by D. Okay, meaning you just choose any one force, which is 20 Newton, and multiply it by the total distance between the two forces. 2 plus 2, 4 meters. So we get our answer. 4 into 20 is 80 Newton meter. And either you use the sign convention or you mention the direction. So because of this, the meter rule is going up and here it's coming down. It's anti-clockwise. So either you can write plus 80 Newton meter or you can mention anti-clockwise. If you were to break this sum, okay, it would have taken a longer time. So the moment due to this force would have been 20 into 2, 40 Newton meter anti-clockwise. Moment due to this force would also have been 40 Newton meter anti-clockwise. So total becomes 80. Okay. All right, students. Now this is a question for you to solve. A uniform meter rule is pivoted at its 50 centimeter mark as shown below. So here's the diagram. And we need to calculate the resultant moment. Please solve this and mention your answer in the comment box. Thank you. See you again in the next video.